Hello everybody, I'm Maya and today I will show you how I have made my movement system, which includes the slippery collision against walls. As you can see, we have here a pretty smooth movement, and if we collide against a wall, we will slide away from him. Okay, so let's start. So first of all, we will have to create our two objects. The solid object with the solid box checked and our player, which will move. And the player at the create event, we will have to write those three lines. We will have to declare an acceleration variable and our max speed variable. This function that I type here only creates these two variables that will be called on our following functions. Then, when we have our create event done, we will have to go to the step event. On the step event, we will check for our inputs, but I won't teach you how to do it because I think that this is not the point of the tutorial. The only thing that we have to care about that is that we have to have a movement direction and to check if we want to move or if we don't want. Once we have our direction and if we want to move, we will call this function that I have called move, and we will type our acceleration, our direction, our max speed, and if we want to move. So now I will show you how does this script works. Okay, so our move script is just a group of scripts. The first script is getMoveVector that will take our old movement vector and will update on the direction that we want to go and in a distance of the acceleration. Then when we have our new movement vector, we will update our position and check for the collision. Our getMoveVector will check if we are moving, and if so, we'll add our old speed and our old direction to our new direction in the acceleration amount. Our addVectors function is just a mathematical script that decomposes the first vector, then decomposes the second vector, and adds each vector to create a final magnitude and a final angle. Then returns an array with the magnitude and the angle. When we just have added our vectors, we will update our speed and our direction. And if our speed is higher than our max speed, we will cap it. Then if we are not moving, we will decelerate in the acceleration amount and our direction won't be changed. Then when we executed all the script, we will return an array with the speed and the direction. Once we have our move vector, we will call the update position script and we will give him the speed and the direction. Here is our update position script, and let's start with it. First of all, I will decompose our speed and our direction into an x and y coordinate. How I do it is with the length dir x and y function, taking the speed and the direction. Then I will check if where I want to go is free, and if it's so, I will update our position. If it is not, we will enter on a loop. This loop will go from 1 to 89, that will represent from 0 to 90, in an amount of our angle precision. We can check 1 to 1 from 0 to 90, or we can jump in an amount of 2 or 3 as you think is necessary. I found that with 10 it works pretty good, but it won't be so precise than with 1, but with 1 will take much more computing processing. When we are in each iteration of our loop, we will check from our angle and the opposite direction of our angle. So if we are on 45 degrees, we will check up 45 and down 45 from our angle. Here we add our current direction plus the angle we are iterating plus our multiplier. So if the player is looking on the 180 degrees direction, we will add the iterator and the direction of the iterator. Here is where I calculate the new speed of my updated direction. If the difference between the two directions is higher, the speed will be decreased, and if it's lower the difference, my speed will maintain like the original. Here I calculate the new target, taking care of my original speed and the multiplier for the speed and the angle I have to check. And then if there is a free place, we will update our position and then exit from the script without having to iterate in the other loop pods. To end our movement script, we will just have to update our speed and our direction in order that we can use them when we want to change them here. So with this we will have finished our movement script, and if you can see, I think that it's a pretty good one. It might not be the best in terms of computing economy, but I think that has a pretty professional looking. So thanks for watching, and I think that this could have helped you all. Bye.